these series are a little bit different. We've introduced the variable x here. So we have n, which is the index for our summation, and then we have the variable x. And what we're interested in is what values of x will allow the series to converge, and then for those values of x, what will be the sum of the series. Number 9, the sum of n equals 0 to infinity of x to the n over 2 to the n. So I'm going to rewrite this as the sum from n equals 0 to infinity of x over 2 all raised to the n. So my r is going to be over 2. And then we know for a geometric series, in order for it to converge, we need the absolute value of r to be less than 1. So I'm going to take the absolute value of r, which is equal to the absolute value of x over 2, and I'll set that less than 1. To solve that inequality, I'm going to rewrite that as -1 less than x over 2 less than 1. And then I'll multiply through by 2, so I get -2 less than x less than 2. So those are the values of x that will allow this series to converge. And for those values, it's going to converge to my first term over 1 minus r. So 1 minus r is going to be 1 minus x over 2. And then my first term happens when n equals 0. So if I plug 0 in here, I get a 1. So this will sum to 1 over 1 minus x over 2. Okay, so number 10 isn't in summation notation. So let's go ahead and put it into that form of notation first. So my first term is 7. So I actually want to factor a 7 out like I did in some of those previous problems so I can see this series more clearly. That leaves me with a 1 minus a 3x plus a 9x squared minus a 27x cubed plus dot dot dot. So 7 is my first term, that's my c. And my r, so remember I can calculate r using any two adjacent terms, so I'll use the -3x over 1. So that gives me r is equal to -3x. And for convergence, I need the absolute value of r, which is equal to absolute value of -3x, to be less than 1. So to solve that inequality, I'm going to do -3x is greater than -1 and less than +1. I'll multiply through by that, or divide by -3 all the way through. So -1 over -3 is a 1/3. And that leaves me with an x in the middle. And then 1 divided by a -3 gives me a -1/3. And anytime you multiply or divide by a negative number, the inequalities flip sides. So this series will converge for x between -1/3 and +1/3. And it's going to converge to, I know my first term is 7 here. And my r is this -3x, so I get 1 minus a -3x. Okay, and if you were interested what this looks like in summation form, that's the sum of 7 times -3x raised to the n. Okay, so if you wrote that down, there you go. You can match it up and see how that looks. All right, and then we have one last one, so number 11. So we scoot this paper so we can see this. I have the sum of n equals 0 to infinity of 4x minus 1, all raised to the n, over 5 to the n. So I'll go ahead and rewrite this one as the sum of n equals 0 to infinity of 4x minus 1 over 5, all raised to the n. That makes 4x minus 1 over 5, my r, so it's a pretty complicated r there, but that's okay, we've got this. So for convergence, I know that the absolute value of r, which is the absolute value of 4x minus 1 over 5, has to be less than 1. So to solve that inequality, I have 4x minus 1 over 5 is less than 1 but greater than -1. I'll multiply through by 5, so that gives me -5 less than 4x minus 1 less than 5. And then I'll add 1 to all the pieces. So if I add 1, I get a -4 less than 4x less than 6. And then last but not least, I'll divide through by 4. So negative 4 over 4 is a negative 1, which is less than x, which is less than 6 over 4. So those are the values of x that will allow my series to converge. Oops, let me scoot that up a tiny bit there. And what it's going to converge to, so I know my denominator is 1 minus r, so I get 1 minus 4x minus 1 over 5. And then the first term is going to happen when n is equal to 0, and anything raised to the 0 is 1. So this will sum to 1 over 1 minus the quantity 4x minus 1 over 5. All right, good luck.